Okay, so really quickly, we're here to teach you how to create a mathematical model from your data. So other names for mathematical models are expressions. We turn expressions into equations. It's also when you combine a little different area of math called statistics, which is technically what we're doing. We call these regression equations. So if you want to take notes on that, a regression equation is a mathematical model that helps you graph lines and use all the mathematical tools to represent the data so you can figure out what's going on. So that's what we're going to do today. You guys have done a really good job doing this with linear equations by hand, using the common difference as the coefficient, and then figuring out the zero term. And we want to help you with things that are not linear. As many of you noticed with the data we're working with currently, this is not a line, although we could try and model it with a line. What we do is say, okay, if it's not a line, is it a geometric one? Is it quadratic? And there are various ways for us to determine that this is quadratic. And we went over that in class, but it involves the second difference from the outputs. So you can look here and see that the first difference is 2, 3, 4, etc. And the differences of those is 1. So it's the fact that it's equal tells me it's quadratic. So if I do that, I'm going to want to jump into here and write up a regression equation. And one thing that's going to help me is to use this keyboard that comes with Desmos. So I'm going to type in y, hit this, and you'll notice this subscript. The data I'm using has a subscript of 1, x sub 1 and y sub 1. So I want to tell Desmos I want to use that data by using this subscript, and I'm going to type the number 1. See, it already says, oh, there's 5 elements in y sub 1. So that tells you you're on the right track. And yours might be different depending on how many elements you have in that side of your table. But you'll also notice my cursor is still blinking in the subscript. So I'm going to use the right arrow on my keyboard, and now you'll see it's bigger. Then I use this little squiggly line over here. This is called a tilde. But in computer world, this is meant to be approximately equal. So when you're dealing with regression equations or models, it's never going to be perfect, or rarely will it be perfect. So we want the best approximation we can. So we do that. And then I use a as my first coefficient because I don't know what it is. In fact, I'm asking this to tell me what it is. And then I come over here to x, and I use my subscript again, and I type in 1. That says use the list from the x sub 1 to help find the expression for y sub 1. That's all the communication going on in this. And then I use the right arrow again, click into the numbers, and I'm going to use this square, and you'll notice my blue line is starting to approach the green dots a lot better. From there, I hit plus. I'm going to type in the letter b for the coefficient on the x term. I need to remember to tell it to use x sub 1, so I'm going to use this again and type in 1. Hit my right arrow, and then I'm going to type in plus and c. And you'll scroll down here and you'll see that it thinks that it should be 1/2 x squared plus 1/2 x. And then this number, just a note, this is scientific notation, which we covered later in 8th grade. But this minus 16 means this is a negative, a decimal point, and 15 zeros before it gets to 2. So you can effectively say this is 0. With that said, I'm going to hide this keyboard and show you how perfectly my blue line, which is modeled by this regression equation, goes through my green points. And I would say that's a really accurate model. So hopefully you can watch this video with some other data and learn how to do this yourself. It's a very powerful tool for both mathematics classes, but more importantly for your science and your social science classes like economics and psychology you may take someday. All right, that's it for now.